the second semester of senior projects. We're going to do that, and Dr. Bednar will go through all the details here shortly. I want to make one special comment, and that is we have, to the request of students 3 years ago to get closer together with the engineering students, the various disciplines to work on projects. So we don't have only one discipline working on a project. Dr. Bednar and I have tried to make sure we can do that. And this year is, I think, we're doing very well in getting this all done. And I thank you and the teams for working together. And I think you understand that no team is a single discipline. And I really appreciate that. And I'm glad that you all can work together. I'm going to say thank you. Good luck. I'm sure you'll all do very well. And turn this over to Dr. Bednar.
Okay. Thank you, Professor Taylor. All right, so welcome. I'll also echo the welcome. So here's our schedule for the logistics. As Professor Taylor mentioned, we're going to start out with all the 391 teams. Their ultimate goal is the design. And then the 392 teams, they're graduating this December, so you're going to see not only have they completed the design, but they've actually built and tested their prototype. So I encourage everyone to stick around for the entire day's proceedings. We have 3 teams going in the morning, and then a quick 10-minute bathroom break, or you want to grab a drink, and then 3 more teams, and then we have box lunches coming. Thank you, Francesca, for ordering the lunches for today. And then kind of 3 more teams in the afternoon, quick break, and then we're going to finish with the Senior Projects 2 teams. And we should be out of here by 2:20. So I kind of pride myself on keeping everyone on schedule, and I really appreciate that you keep yourselves on track. So I'll have my phone with my timer. So you're going to have 15 minutes to present, and then the faculty will have 5 minutes to ask questions. If there's a lot of questions and we kind of keep going, I'll probably even cut off my colleagues and say, hey, why don't you find that team during a break or lunch, you know, if they really want to have more questions. I kindly ask everyone silence your cell phones, right? But I'm going to break my own rule because my wife is 39 weeks pregnant, so I need to have mine available just in case I get a phone call. But as far as I know, no baby coming today. Okay, any questions before we get started? I think everyone's prepared. They've been doing the practice presentations to all their advisors throughout the semester, so I think you're going to be excited. My son Eddie's passing out forms for evaluation for faculty, so if you haven't already gotten a schedule or form, he could run you a form. And here's what it's going to look like from my end. I ask that the faculty evaluate on presentation organization, execution, amount of work done, and design completion for the 391 teams. And then for the 392 teams, add a category for prototype and testing. So basically I want to keep the grading pretty simple, just 0 to 20 points for each category. And then I'd like to welcome any guests we have from industry. We have 3 industry-sponsored projects, Quantum Rehab, Mitsubishi Chemical, and Cornell Cookson. And any alumni guests, David's here as a guest. Did you have a question too, David?
Yeah, our questions come to faculty?
No, yeah, any of our guests with engineering degrees can ask questions as well. I think that's pretty much it. I have everybody's presentation loaded, ready to go here. Let me maybe download it to the desktop so we don't have any lag. But I went off of military time, so you should see everyone's here. We have 0910 all the way up to 1350. Okay, all right, so let's get started. We're right on time for our 0910 team, Quantum Rehab.
Dr. B. Clicker. You have that clicker? Here's the clicker. Go without it.
current test fixture at Quantum Rehab. It was originally designed and manufactured in the early 2000s. So basically, Quantum has outgrown it. They need something new, especially since there are some tests on this that are no longer performed. The tests that we are currently looking at to try and implement into this one are the speed test, which also includes the turn test with the white rollers, the caster test with the conveyor belt on the front, and then the voltage test with the digital multimeter on the control panel. So we have some requirements that we obviously need to follow for this, especially since we're an industry-sponsored project. We were able to break it down into 6 different categories, and we went to Quantum and basically formed with their requirements so that they know what they are getting and we know what we have to give them. This ranges anywhere from how big the test fixture itself has to be, how many tests should be performed in a single day, how long each test should take, how fast some of the rollers need to spin in order for the test, like the turn test, the speed test, or the caster test, to give accurate results that Quantum, that gives accurate results for Quantum. And moving on to some more requirements that we have for Quantum themselves, whenever we're purchasing materials for the test fixture, we need to make sure it goes through their own approved supplier list, and we also need to approve any expenses from them themselves. We need to also give them a detailed drawings package so that they know what they're getting. If they have any changes that they want us to make, any recommendations, they can give them to us before we start building. Any instrumentation that we implement into this test fixture is going to be just for the test that they want to currently run. Nothing extra. We also want to reduce the clutter, and as mentioned before, nothing outdated. And we're going to go for the Quantum color scheme of black and gold.
All right, so moving on to the specifications. So we have 4 different components. So the lift table, voltage test, the speed test, and the caster test. Our lift table is going to be 48 by 48 inches. The height of the lift table listed above with a voltage of 110 VAC. Moving on to the voltage test, this is incorporated within the rollers as listed on the design. That'll run between 0 VDC to 30 VDC. And then with the speed and caster test, they will be incorporated, as Joe said, into that roller design, and also the caster test will be behind that roller design with the seamless belt. Moving along. This is our WBS with 5 different categories: design, procurement, documentation, testing, and there's also install. Moving along here with the team responsibilities, each of us has a specific role within the project that will be complete by the spring 2023 semester. For the mechanical side, Alex will be taking care of the lift table and frame assembly. Joe will be taking care of the speed test assembly, which are those white rollers as was said before. Myself, I will be taking care of the caster assembly, which is the conveyor belt system. And lastly, Tyler will be taking care of the PLC programming and additional design. On the electrical side, Zach will be taking care of the speed and voltage test. And then Tyler will be assisting with caster and lift table electrical design. Breaking down what our schedule looks like. So pretty much what we started out with this semester was getting all those requirements and specifications from Pride/Quantum, making sure we have everything correct and what they need. Then moving along, we started our design process all the way up to the end of the semester here. We have that final 3D model as shown before. And then in semester 2, we will make sure we have everything correct with what Quantum needs. And then we'll issue a drawings package
machine modeling. The load of 373 pounds represents the worst-case scenario that the machine will face. There are two key takeaways from this. The first is that our safety factors are all